folks, welcome to number 6. This one is going to be an intense one. I've got a rational inequality and I have a 2 over here. And if I want to do any of these rational inequalities, I need a 0 on this side. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So when I subtract 2 from both sides, I've got x squared minus 1 over x squared minus 2x minus 3. I'm going to subtract 2 so I can get that 0 to pop out. And the thing is, I'm going to need some common denominators, right? So if I want to add, or in this case, subtract fractions, I'm going to need common denominators. So let me go ahead and factor that denominator. So if I look at this, this is going to be x squared minus 1. And if I factor that quadratic trinomial in the denominator, I've got x minus 3, x plus 1, right? And this is essentially 2 over 1, right? So my LCD is gonna be x minus 3x plus 1. So I'm gonna multiply this fraction, 2 over 1, by x minus 3x plus 1 over x minus 3x plus 1. So let me just start combining that so I don't lose space, because this is gonna take a while. I'm gonna need all the blank space I can. Okay. So you can see I'm gonna have common denominators in a bit, which is a good thing. So I'm gonna keep my denominator and subtract my numerators. And I'm gonna remember not only to distribute that 2 to either the x minus 3 or ultimately I'll FOIL these and distribute that 2 in, but I need to subtract every term on that second numerator. So I'm gonna be real careful when I do this, all right? So keep in mind, we already know x minus 3 times x plus 1 is x squared minus 2x minus 3, right? So I'm gonna FOIL these and I'm gonna do a little bit of algebra. So I've got my numerators of x squared minus 1 minus 2 times x minus 3 x plus 1 all over x minus 3 x plus 1. All right, and that is less than or equal to 0. Okay, so here's what I'm saying. Like, I know x minus 3 times x plus 1 is this trinomial, right? That's how we got from here to here, was we factored it. I'm gonna multiply it back out. So I've got x squared minus 1 minus 2 times x squared minus 2x minus 3 all over x minus 3 x plus 1. That's going to be less than or equal to 0. Okay, we're going to keep going. Now I'm going to distribute this 2 and this negative to every single term in this trinomial. So this is going to be minus 2x squared plus 4x plus 6. All right, and then I'm going to combine some like terms. So let's see what we have here. X squared minus 1. All right, minus 2x squared plus 4x plus 6 all over x minus 3 x plus 1. It's still less than or equal to 0. All right, let's start combining terms. So it looks like I've got x squared and minus 2x squared. All right, let's go put this together. All right, I know this is still less than or equal to 0. X minus 3x plus 1. Okay, on the numerator, x squared minus 2x squared is minus x squared. All right, I've got a 4x here. I've got no other linear terms up here. And then I've got minus 1 plus 6 for my constant. So this is going to be plus 5. All right. Now for me personally, I don't like having a lead negative. So I'm going to factor that out. And for space sake, I'm going to move that over here. So I'm going to start this mess here. So I'm going to factor the negative out of the numerator. All right, so I'm going to leave the denominator the same. So my first step is I'm going to write my denominator in less than or equal to 0, and then I'm going to go factor this. So I'm going to keep my denominator of x minus 3 and then x plus 1. Okay, less than or equal to 0. When I take the negative out of this numerator, I'm going to be left with x squared minus 4x minus 5. And I think I can break this down. I can think of 2 numbers that multiply to negative 5 but add to negative 4. So let me go write this. I'll have this negative. All right, and I'm going to make some factors up on top. So 2 numbers that multiply to negative 5 and add to negative 4 are going to be minus 5 and plus 1. All right, so we've got x minus 3, x plus 1. All right, and that's all going to be less than or equal to 0. Okay, so now I need to figure out where things zero out. If I look at the numerator, I've got 2 separate factors. So my zeros from the numerator, or I'll just say my critical values, the things I want to look at, I know I'm going to have a critical value or a 0 at 5, and then negative 1, and then I'm going to add 3 to that. All right. Now, if we were graphing this, which is a different question, All right, this is just a quadratic, or excuse me, a rational inequality. If I ever asked you to graph this function, right, which we will do, there'd be a hole at -1, an x-intercept at 5, and a vertical asymptote at 3. And that's all good. It's just, that's not relevant to this question. I need to go make a sign pattern, all right, which is the next thing I'm going to do over here. And then I need to figure out where things are less than or equal to 0. So I'm going to draw my little smushed number line. Okay, and I want to make sure we can see all this. Yep. All right, so here we go. So I will put my x values that are interesting to me on the bottom. So, and I'm going to go from low to high. So -1, 3, and 5. And then I'm going to put my expression, which is a lot to write in right now, here. Okay. So when x was -1, that denominator zeroed out. So this expression is undefined. All right, when x was 3, the denominator also zeroed out, so that fraction would still be undefined. When x was 5, the numerator zeroed out, and anytime your numerator is 0, your fraction is 0. All right, and so it's important to figure out if these are undefined or 0, because I am ultimately going to be looking for where things are less than or equal to 0. I can already spot 5 is where my expression is equal to 0. And almost based on that, almost based on the fact that I know 5 has to be in my answer, I can see that option A doesn't have a 5 in it. It's not going to be A. Option B doesn't, oh, actually it does have a 5 in it because 5 is in between 3 and infinity. So I can't rule that one out. Here I have 5 included and here I have 5 included. So just based on the fact that this says less than or equal to 0, and here's where I'm equal to 0, I need to include 5 in my answer so I can rule out the answer from part A. All right, so now it's a bunch of, let's do pluses or minuses. All right, so now it's up to you if you want to use ordered pairs to figure this out, or not ordered pairs, if you want to use test points to figure it out, or you want to go lead negative. So I'm going to do it both ways, just so you can see this. I'm going to do it the faster way first, all right, and then I'm going to go ahead and do it the test point way. So there is a lead negative, which means I would have a negative here. As I move this time right to left, this is really one of the only times we go right to left. I look at this 0 of 5 came from this factor of x minus 5. And since it had an odd multiplicity and that there was only one of them, I'm going to alternate around that sign, or around that 0. Then I get to 3, which was undefined, but it came from this factor of x minus 3, which also had an odd multiplicity. So I'm going to alternate, right? I'm going to change from minus to plus and then plus to minus. But -1 came from this factor of x plus 1, and there are 2 of them because there was 1 here, 1 here. So since that factor showed up an even number of times, the sign does not alternate around -1. It'll stay negative. And if you didn't like any of that, let me erase all these. Let's do it the longer way, which is still totally valid. All right, and I would say in the beginning I had to do it this way. So you pick test points. So I think of something to the right of 5. Something to the right of 5 is like 6. All right, so if I want to collect this, all right, I'll have a negative from this lead negative. 6 minus 5 is going to be positive. 6 plus 1 is positive. 6 minus 3 is positive. 6 plus 1 is positive. So if I have a negative times a positive, 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 the lead is negative. All right. A great test point in between 3 and 5 would be something like 4. All right, I've got my lead negative. 4 minus 5 is negative. Let me change that up. 4 plus 1 is positive. 4 minus 3 is positive. 4 plus 1 is positive. Negative times a positive, positive, positive is positive. A great test point, and I'm going to erase my little test points because they're not technically part of my number line that I need. All right, another great test point in between -1 and 3. I love to pick a 0 when I can. So lead negative, 0 minus 5 is negative, 0 plus 1 is positive, 0 minus 3, this is now negative, 0 plus 1 positive. So 2 positives, 3 negatives gives me a negative. And let's move to this last little interval. All right, I will pick, I'll just go with -7 over here. You could also pick -2 if you were thinking that. All right, -7 minus 5, negative. -7 minus 1, ooh, negative. Let's change that. -7 minus 3, negative. -7 minus 1, negative. All right, Negative, 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 negative means negative. So there we go. So I've got my sign pattern, okay? Now I want to collect where are things less than or equal to 0. So I want to look for the negative symbols and I want to look for the zeros. So let's go ahead. I've got a negative here, a negative here, and a negative here. So I've got 3 intervals that are negative and I want to write them up. And I also want to include, I want to open, or a closed dot here. I want the 0, sorry. I found all the negatives. I forgot to include the 0. So we're going to say negative infinity and negative 1. I can't include negative 1 because it's undefined. I can't include 3 because it's undefined. But I can include 5 because that's where it is equal to 0. And that is going to match D. All right. Thanks so much, everyone. Bye.